April 16, 2013. Coyote, California, south of San Jose. Just before 1 in the morning, someone lifts the covers from underground communication vaults beside Monterey Highway and cuts several fiber optic cables. The work is quiet. No alarm reaches the people sleeping nearby. About half an hour later, rifles begin firing through the darkness toward the Metcalf electrical substation. The shooters remain outside the fence. They never enter the control building. They never touch a switch. Yet within 19 minutes, 17 transformers are leaking oil, operators are rerouting electricity, and Silicon Valley is moving to a blackout nobody can see. The target belongs to Pacific Gas and Electric. It sits near Highway 101, where transmission lines carry power toward San Jose and the technology companies surrounding it. Inside the yard, rows of steel equipment step voltage through the network. The most important machines are transformers filled with insulating oil. They are expensive, heavy, and often designed for one location. A replacement cannot be driven from the warehouse. Manufacturing can take months. Transportation requires special rail cars, trucks, permits, cranes, and carefully planned routes. The attackers do not need to destroy the shells. They only need to damage what keeps them alive. Long before the first bullet, the communications cables are cut. Investigators later consider whether the sabotage is part of the same operation. The timing makes it difficult to dismiss. Telephone service in the area is disrupted, and some communications become less reliable. The shooters appear to understand that confusion has value. A report buys time. A broken connection slows coordination. But they do not sever every line, and the purpose remains uncertain. The attack contains signs of planning without revealing a plan. It is organized enough to look deliberate, yet restrained enough to leave investigators asking what the objective was. At 1:31 a.m., gunfire begins. The rounds come from positions beyond the perimeter, aimed through the fence at the transformer radiators. More than 100 shots are fired. Evidence suggests at least 2 rifles. The attack lasts about 19 minutes. Bullets puncture metal fins and pipes carrying cooling oil. Dark liquid spills into containment areas below. As oil levels fall, temperatures rise. Protective systems detect the change and remove equipment from service before it fails catastrophically. The method is simple, the consequences are not. Each disabled transformer reduces the number of paths available to move electricity across the transmission network. Someone at a power plant hears the shots and contacts authorities. Deputies reach the area after the firing has stopped. The gunmen are already gone. They leave behind damaged equipment, spent ammunition, and questions. Investigators find no bodies, no abandoned vehicle, and no message. The shooters may have removed evidence before leaving. Their positions suggest preparation. Their exit suggests discipline. Nothing indicates panic. Nothing explains motive. The scene looks less like random vandalism than a task completed on schedule. Still, precision does not prove expertise. A patient observer could study the substation from roads and learn where components stand. While police search the perimeter, grid operators confront an emergency. 17 transformers are no longer dependable. If power continues flowing through the damaged yard, overheating or failure could make the situation worse. Operators shift generation, redirect electricity, and rely on transmission paths. The network bends around the equipment. Customers do not lose service. Offices remain lit. Data centers continue running. Traffic signals keep changing. The response is effective that the public barely notices. That becomes one of the strangest features of Metcalf. The attack is serious enough to transform security policy, but quiet enough to vanish beneath a California morning. The absence of a blackout does not mean the damage is minor. Repairs cost more than $15 million and take a month. Crews must drain, inspect, repair, test, and refill equipment before the station can return. Transformers are difficult to replace because many are made for specific sites. They weigh many tons. Moving one may require rail access, roads, specialized trailers, escorts, and cranes large enough to lift a house. A coordinated attack against several critical sites could create a problem measured not only in outages, but in the time required to rebuild machines the grid cannot replace. Former regulator John Wellinghoff studies the attack and reaches a conclusion. He calls it the most significant incident of domestic terrorism involving the American power grid. The FBI does not adopt that description. Terrorism requires evidence of a political or social motive, and investigators have no manifesto, claim, or group. The distinction matters legally, but it does little to reduce the risk. A rifle attack can threaten infrastructure without announcing an ideology. It can be sabotage, revenge, preparation, or something investigators have not imagined. Metcalf demonstrates that the grid can be tested by people who never explain why they came. Investigators focus on the shooting pattern. The attackers appear to aim low, toward cooling systems rather than the armored cores. Some reports describe piles of rocks placed near firing positions, used to mark locations in darkness. Spent casings are limited, suggesting the shooters may have gathered them. These details produce an image of coordination, but they do not reveal training. Hunters understand rifles. Workers understand machinery. Anyone with time can observe a facility. The most disturbing possibility is not that the attackers possessed knowledge. It is that the knowledge required may have been visible from the side of the road. Metcalf also exposes a problem in security thinking. Utilities have spent years defending digital control systems against malware, stolen credentials, and remote intrusion. Those threats are real. This attack uses no code. Nobody enters a password. Nobody compromises a server. The shooters use rifles against equipment placed in open view. Traditional substation fences are designed mainly to prevent accidents, theft, and unauthorized entry. They create distance from dangerous voltage. They do not stop bullets. Cameras can record an assault, but recording is not resistance. By the time an alarm is reviewed and officers arrive, 19 minutes may already be enough. The response reaches Washington. In March 2014, the Federal Energy Regulatory Commission directs the North American Electric Reliability Corporation to develop security requirements for the bulk power system. The standard is called CIP 014. It requires utilities to identify transmission facilities whose loss could cause instability, cascading failures, or uncontrolled separation. Those facilities receive threat assessments and security plans. Reviewers examine the work. The rule does not turn a substation into a fortress. It creates a process for deciding which locations matter most, what threats they face, and how owners should reduce the consequences if barriers, cameras, guards, or redundancy fail. PG&E begins hardening Metcalf and other sites. The company commits $100 million to stronger barriers, improved detection, additional cameras, lighting, and guards. At Metcalf, opaque walls block views of critical equipment. Security becomes layered. An attacker must now defeat distance, visibility controls, alarms, and a faster response. Yet protection has limits. The United States contains tens of thousands of substations spread across cities, deserts, forests, and farmland. Defending all of them like military bases would be enormously expensive. Utilities must prioritize, which means the grid depends on assessments that outsiders cannot examine, and attackers may try to outguess. The standard produces a contradiction. Identifying the most consequential facilities is necessary for protection. Publishing that list could create a guide for attack. Much of the analysis therefore remains restricted. Communities know the grid is essential, but not which sites carry the systemic risk. Regulators know security plans exist, but defenses vary by owner and region. A wall may block bullets, spare equipment may shorten recovery, alternate lines may keep power moving. None of these measures guarantees that coordinated losses will remain manageable. The network is resilient because it has options. An attacker would look for places where those options disappear. Later attacks show that Metcalf was not unique. In December 2022, gunfire damages 2 substations in Moore County, North Carolina. Tens of thousands of customers lose electricity. Homes go cold. Businesses close. Traffic lights stop. The outage lasts for days. During the month, 4 substations in Washington state are attacked. Prosecutors later say 2 men caused those outages to create darkness for a burglary. The motives are different, but the mechanism is familiar. Small groups can reach exposed equipment faster than utilities can replace it. An electrical system built for efficiency and reliability must now account for deliberate human interruption. Metcalf matters because it sits between failure and catastrophe. The attackers disable 17 transformers, but operators prevent a blackout. They reveal a weakness but do not exploit it far enough to show the worst result. That leaves every assessment trapped inside a counterfactual. What if the shooting had continued? What if a second substation had been hit? What if spare equipment was unavailable, communications failed, or demand was higher? Engineers can model those conditions, but models depend on assumptions. The event supplied one test. It showed that a few people could damage a transmission site and leave before police arrived. The investigation generates theories but no proven answer. For years afterward, no arrests are announced. No courtroom reconstructs the operation. No known witness ever explains the cables, the firing positions, the missing casings, or the timing. The walls at Metcalf rise higher. Cameras gain better angles. Regulators give the lesson a standard number. Electricity continues flowing toward Silicon Valley, feeding factories, homes, and data centers that have become more dependent on uninterrupted power. The attack survives mainly as a national security case study, yet its central fact has not changed. Someone tested America, learned what happened, and walked away unnamed.